Hi guys, it's Dr. Justin Southey here. I'm going through a couple of tutorial questions on limits and continuity, and we ask here to determine the set of points at which this function is continuous. So it's a piecewise defined function, so we've got to look at the different pieces. Now the first piece is a rational function, so it's continuous on its domain. So we need to know what its domain is. Well, its domain is anything provided that the denominator is non-zero. So we want to know when is x squared plus xy plus y squared is equal to 0. When does this happen? Well, it turns out that the only time that this happens is when x and y are both equal to 0. Now, in order to show this, if you've got a nice simple way of doing it, please do come and show me. The only way I could do it was to use the quadratic formula to have x is equal to minus b, so b in this case is y, so minus y plus or minus the square root of b squared, so that's y squared minus 4ac, c is y squared, so minus 4y squared, all over 2a, so all over 2. And if you look in here, well, okay, let's just write this y minus y plus or minus the square root of minus 3y squared, all over 2. Now here we've got a negative 3 times a positive number, or rather a non-negative number. The only way for us to not have the square root of a negative number is for y to be 0. So therefore y is equal to 0, and therefore x is also equal to 0. But like I say, if you've got a simpler way of showing that this thing has only those two solutions, please do come and show me. Well, what does that tell us? That tells us that this thing is continuous everywhere except at the point 0, 0, because it's continuous on its whole domain. So the only point that we actually have to worry about is the point 0, 0. And it's certainly defined at 0, 0, but we need to know if this limit exists. Three things for continuity. The function must be defined at the point, the limit must exist at the point, and the function value must be equal to the limit value. So we've got it's defined, we now need to check if the limit exists. Well, let's first try and show maybe that it doesn't exist. We're going to try and find two paths that give us different limiting values. And the first thing we're going to try is we're going to approach along the x-axis. Approach along the x-axis, that means that our y values are all equal to 0. So now our limit becomes the limit as xy, and y is 0, so x0 approaches 0, 0, of our function. Well, our function now is x times 0, so it's 0 in the numerator, divided by every term with y in it is going to disappear because there's 0, so it's just 0 over x squared. And that, as we know from all the examples that we've done already, if you've watched the other videos, that's just the limit of 0, and we've now got the limit of a constant that's equal to the constant. So that's the limiting value if we approach along the x-axis. If you approach along the y-axis, you get the same value, but let's try approach along the line x is equal to y. Okay, then our limit becomes, well, now we're approaching from x, we're approaching 0, 0, and our function becomes, wherever we've got a y, we're going to replace it with x. So we've got x squared over there, divided by x squared plus x squared plus x squared. So we've got x squared divided by 3x squared. We can cancel the x squareds because they're non-zero, because we're not at the limit, we're just approaching the limit of 0. And we've got the limit of a constant function is equal to simply that constant function, so that's equal to a third. So, as we approach along the line x is equal to y, we get a third. As we approach along the x-axis, we get 0. These are different values. They're not equal, therefore this limit doesn't exist. Limit does not exist. Right, so what does that tell us? Well, we want to know, where's this function continuous? Well, the function's defined at 0, but the limit doesn't exist at 0, so it's not continuous at 0. It's continuous everywhere else because this guy here is continuous on its domain. So therefore, f of xy is continuous everywhere on R squared except at 0, 0. Okay, so this is a very nice question that brings together what you know about limits and what you know about continuity into one question.